this video, we are going to look at definite integrals. I'm going to explain to you what is a definite integral and then jump into a few examples. This will be the first video of many around definite integrals that I will upload. So look out for them and ensure you watch this first before jumping into the new ones that I will upload, because I will cover a lot of the basics in this video. However, before watching this video, please go ahead and watch my video on integrals, especially around the rules of them, and I show you a lot of the indefinite integrals and take you through all of the rules, because the rules still remain the same and we will use them in here. So that will be your foundation before getting into this video. So let's jump into it, right? Before I take you into the examples, I'm going to pose the question: what is a definite integral and what is an indefinite integral? So many of you who maybe have already studied the section might already know it, but I'm going to take you through the difference between the two. So what is the difference between an indefinite integral and a definite integral? So an indefinite integral, we firstly see that we write it as the integral of f of x dx, and that's it. However, a definite integral is written as the integral of f of x dx with the limits a and b. Now, what do the limits a and b tell us? It tells us that for the definite integral, where a and b are the limits, we can now be able to have the final answer as, and I'm going to write this in a different color, we will actually get a number as the final answer. Okay, and if you've watched my integrals videos around the indefinite integrals, you know that for an indefinite integral, we would get an answer with variable x in it, and basically we would have it written as some variable x plus c, which is the constant in that case. And if you can see the difference here, this and this, we're saying we get an answer. For an example, we will just get an answer of 10. But here we will get, like I said now, we will get an answer in terms of x plus c. There is no plus c in the definite integrals. So that's one part, or one part of the difference. The other difference between the two is the fact that in an indefinite integral, we are looking to find, or we find a function to the question. So we basically try to answer the question, what function when differentiated gives us f of x. So that's basically what we're trying to find in the indefinite integral. And on the definite side, we are looking to represent, it represents the area under a curve from where x equals a to where x equals to b. So that's basically the difference. We're trying to find a function with the indefinite integral, and with the definite integral, we can actually represent the area under a curve between the two limits that we are given, which is a and b. Okay, so taking this one step further, I'm going to tell you about the theorem of the integrals for the definite integral and the indefinite integral. So this is written as, so the fundamental theorem of calculus tells us, and I'm going to write this out in words, so just for you to understand it, and I'm actually going to show it to you mathematically. So it says that 2 compute a definite integral, we need to find the antiderivative, which is, as you know, called the indefinite integral. So we basically need to find the indefinite integral of the function, and then we need to evaluate the function at the endpoints where x equals to a and x equals to b. So all this is saying that when we have a definite integral, we need to first find the indefinite integral. So find the function first for the antiderivative, and then we look at applying the limits where x is equal to limit a and x is equal to limit b. Okay, so this basically looks like, if you want to look at it mathematically, it basically says that if we have the integral from with the limits a to b of f of x dx, we want to find the antiderivative of f of x with respect to b minus the antiderivative of f of x with respect to a. And just to call this out, this can also be written as f of x with limits a to b. So take note of this, right? I'll be using both of these notations during the examples that we're going to jump into. And let's go ahead and jump into our first example. As usual, have your rules of integrals next to you. I'm not going to go through all of the rules, but I will call out what rule I am using in the examples. So have your rules next to you. Feel free to pause the videos when we're going through the example. Try to find the answer first and then check whether it is correct with what I am going to show you up next. So stay tuned. We're going to head into the examples straight away. Okay, so let's start getting into the examples. Let's look at this example where we want to find the integral of 5 dx of the limits 3 to 4. Now remember the theorem, we want to find the function of f of x first. So that's our 5 dx here, and then we plug in the limits. And if you go back to my integrals videos, you will know that this here is basically the constant rule. And if you want to find the integral of a constant, that is basically equal to 5x. We want to evaluate it from 3 to 4. Okay, now also remember the theorem that we just mentioned. This is basically, we want to find f of b minus f of a, and if we look at that, that is basically 5 into, this is our b, this is our a, so we're finding b first. So 5 into 4 minus 5 into 3, and that is basically equal to 20 minus 15, and that's equal to 5. Now remember what we said for a definite integral, we will always get a number, and here we have it. This is a number. Okay, let's look at another example. Let's look at, if we want to find the integral 1 to 3 of x squared dx. Okay, now this we can already see is the power rule, and the power rule says if we have x to the n, that is x to the n plus 1 all over n plus 1. So this is basically equal to 2 plus 1 is 3 all over 3, and we're evaluating this from 1 to 3. And remember fundamental theorem calculus, you want to find f of b minus f of a. You don't need to write this out. I'm just trying to link it back to the fundamental theorem of calculus for you. So the answer we'll get here is 3 cubed over 3 minus 1 to the 3 over 3, and that's equal to 27 by 3 minus 1 by 3, which is basically 9 minus 1 by 3, and we will get an answer of 26 by 3. Coming back to this 3, 9 times 3 is 27, minus 1 is 26. Okay, so that's your second example where we use the power rule in it. Let's look at another example. Let's look at something like this. Let's say we have to find the integral of 3x squared dx, and we make it definite, so we're finding it from 2 to 3. So here we can use the multiplication rule as well as the power rule. So this is basically equal to, or we can rewrite it as 3. This is the multiplication of a constant rule. So we take out the 3 and we find the integral from 2 to 3 of x squared dx. So now we have the power rule that we need to apply here. So that's basically equal to 3 into x cubed by 3, and we're evaluating this from 2 to 3, and that's equal to 3 into 3 cubed by 3 minus 2 cubed by 3. And if we are looking to simplify this, this is basically 3 into 27 by 3 minus 8 by 3, and that's equal to 3 into, we will get, so if you calculate this will give you 19 by 3, and your final answer is basically 19. This 3 and that 3 will cancel out. If you multiply it out, your final answer is 19. Once again, we got a number for a definite integral. Okay, let's look at another example. So let's look at an example where we want to find the integral from 1 to 3 of 2x minus 3 dx. Okay, looking at our rules once again, this would be our sum and difference rule. So just go back and have a look at that. So what we can do here, we can rewrite this as, we want to evaluate from 1 to 3 of 2x dx minus, we want to evaluate from 1 to 3 of 3 dx. Okay, so taking this forward, this is then, we know we can use the multiplication and the power rule here. This is the constant rule here. So that's basically, we're going to have 2 into x squared over 2. We're evaluating it from 1 to 3. We're going to subtract it from 3x, which is also going to be evaluated from 1 to 3. So plugging in our a and b in this, so the limits, we're going to have this as 2 into 3 squared over 2 minus 1 squared over 2 minus 3 into 3 minus 3 into 1. Okay, and taking this further, this is basically 2 into 9 over 2 minus a half minus 3 times 3 is 9 minus 3. So we're gonna get here, this is basically 2 into 4 because it's 8 by 2, which is 4, minus 6. So our final answer is basically 8 minus 6, which is equal to 2. Once again, we got a number. Okay, so that's an example where we have a bit of a polynomial in here. So looking at what we've done so far and understanding how indefinite integrals work, you may want to ask yourself, what is happening with the c? Or better question is, where is the c? Where is the plus c? So to answer that question, let's go back and look at the previous example, right? So let's look at it again, right? We have the integral of 1 to 3 of 2x minus 3 dx. Okay, now solving for this, we were going to write this as 2 into x squared over 2 plus c into 1 to 3 in terms of the limits minus 3x plus c, 1 to 3 in terms of the limits. So taking it forward, we would say 2 into 9 by 2 minus a half plus c minus 9 minus 3 plus c. Okay, so that's plugging in a and b. And now we want to get to the point where we have this as 2 into 4 plus c minus 6 plus c. And what are we going to do here? This is a minus. We are going to take the minus and distribute that into this. So we would now have this as 8 plus c minus 6 minus c. The c and c cancels out, so we're left with 2 again. Okay, so that's just to answer the question why we are not having c, or if you're very curious as to why we're not including c in this in these examples. Okay, so let's look at another example. Okay, so let's look at this example. Let's say we need to find the integral of 4 over x cubed dx, where the lower limit is -3 and the upper limit is 2. So what do you think we do in this case? So if you look at my integrals video, what we always try to do is let's try to bring this to the top. So this can be written as the integral from -3 to 2 of 4x to the -3 dx. Now it's in a form that we can recognize and understand. So you can see that this is the power rule, this is the multiplication of a constant rule. So using that, we can now evaluate this and rewrite this, or find the integral of it to be 4x to the -2 all over -2, and we're evaluating it from -3 to 2. So if you take this further, this is basically -2x minus 2 minus 3 to 2. So what do you think we can do right here? We can, like what we did in the beginning, we took the x cubed and brought it to the top. We can actually take the x raised to the -2 and take it to the bottom. So this is now equal to -2 over x squared, and we want to evaluate this from -3 to 2. So this is now equal to -2 into 2 squared. Remember, we find f of b first, then minus f of a, which will now be -2, which will now be minus into -2 over -3 all squared. And this, if you do calculate this and do the simplify it, you'll get an answer of -5 over 18. Okay, so just remember to simplify it. Just multiply this out, both of them out, the a and the b, the f of a and the f of b, you will end up with -5 over 18. So you can go ahead and perform that simplification. So let's look at another example. Let's look at one where we have the where we need to find the integral of 1 to the 4 over x dx. Now looking at this, we can just apply the multiplication of the constant rule. So we'll bring out the 4. So we then need to find the integral of 1 raised to the e 1 over x dx. Okay, and if you go back to my rules or my previous video, we know that 1 over x, finding the integral or the antiderivative of it, that's basically just equal to ln of x. Okay, so In that case, we have this as equal to 4, okay, ln of x, and now we can evaluate it from 1 to the e. Okay, so this is equal to 4 ln of e minus 4 ln of 1, and this, we know this here, ln of e is equal to 1 and ln of 1 is 0. Okay, this is also explained in my previous video around integrals, as well as my derivatives video where I went in depth explaining this. So we now have this as 4 into 1 minus 4 into 0, and that's equal to 4. Okay, so our final answer is 4 from this. So quite an interesting example to look at with ln as well as exponential. Okay, e. So let's look at another example. Let's say we have, or we need to find the integral of 1 all over the root of square root of x from 4 to 9 dx. Okay, what do we do first, right? We can rewrite this as, we need to go from 4 to 9 of 1 over, this can be rewritten as x to the half dx. Now we see it has an exponent. So what do we do here? We would now rewrite this as, and we take this to the top, and this is x to the minus half dx. Okay, now we can clearly see that this in here we can just use the power rule. So taking this forward, we would now have this, so we can say that's equal to x to the half all over a half, and we now have this as 4 to 9. Okay, so guys, remember it's x n plus 1 all over n plus 1. So the half plus 1, so it's minus a half plus 1 all over minus a half plus 1, which gives us a positive half. Okay, so that's how we get this. Now we can get rid of the denominator by multiplying everything out by 2. So we can rewrite this now as 2x raised to the half into, or the limits of 4 to the 9. Now what do you think we can do at this step, right? If we go back, we took this, let's just show you, we took this and so the square root, and we were able to rewrite it as this, x raised to the half. Now here we have x raised to the half, so what do you think we can do here? And if you guessed it, we can now take this and rewrite this as 2 root x, and we're evaluating it from 4 to 9. So this is then basically just equal to 2. We want to find the square root of 9 minus 2 square root of 4. So that's basically equal to 2 square root of 9 is 3 minus 2 square root of 4 is 2. And that's going to give you 6 minus 4, that's equal to 2. Once again, your number as a whole is your answer is a number. So quite a neat trick, right? How we could get the square root out into a power form, where we could use the power rule and then take that further and take it into the square root form again, and then find the roots in order to find our final answer. Quite a neat trick, right? I'm going to take you through a final example, and I'm not going to take this through to the end. So jot this down. I'll take you through the first few steps, and then you can finish it off on your own. Okay, so what do we have to find the integral of 4x cubed plus 2x squared minus 3 dx? And we're evaluating this from 2 to 4. Those are limits. So we know already this is we can take it down as a sum and difference rule. So what would we do first in that case? Find the integral from 2 to 4 of 4x cubed dx plus the integral from 2 to 4 of 2x squared dx minus the integral 2 to 4 of 3 dx. Okay, so we know here we can use the power rule and the multiplication constant. So this will be basically x to the 4 all over 4, and you can see that the 4's will cancel out. So we'll have here x to the 4, evaluating it from 2 to 4, plus. Here we're going to do the same thing, the power rule, multiplication over constant rule. So we got 2x cubed all over 3. Okay, so we have 2 over 3 x cubed, and we can evaluate it from 2 to 4 minus we have a constant here, so integral of that is basically just 3x, and we're going to take it from 2 to 4. Okay, so all you need to do now is substitute this out. So we're going to have here 4 to the 4 minus 2 minus we're going to plug in 2 here, so that's going to give you 2 to the 4 as well, plus. Okay, in here we're going to have 2 over 3. Our x will be now 4, so that will be multiplied by 4 cubed minus 2 over 3, and we're going to substitute the 2 in there, so we're going to have here 2 cubed. Okay, minus, I'm just going to go to the next line, we're going to say minus 3 into 4 minus 3 into 2. Okay, and I'm going to leave it as this. Like I said, this is basically where you need to get to. Now you just need to multiply, or just simplify this, multiply out, raise to the powers. 4 to the 4 is 256, and then you can take it from there, right? So go ahead and simplify this until you get to a final answer, which would be where you would need to get for a definite integral. So that takes us to the end of this video. I will post a few more videos, but before I leave, just one thing, if you have noticed, please go back and look at my previous video on the integrals, because that's going to help you a lot here, because you need those rules. Understand the rules, look at those examples where I've shown you, especially in the previous example here, I've done this and shown this a lot in I've shown this a lot here in my previous integrals video. Just one hint from me is if you have given a problem where you need to find the integral of a to a of f of x dx, always remember that this will always be 0, because you're going to evaluate f of a minus f of a basically. Okay, so if the two limits are the same, just know that your answer is going to be 0. Even if it's a very complicated problem, you're going to get to the point where your answer is 0. Another hint is that if you have something like the integral of with the lower limit is 1 to 2 of f of x dx, and you've also given the integral of 2 to the 4 f of x dx. Okay, so remember what we said, this is going to give us the area under the curve when we have the definite integral. And in this scenario, what if you are asked to find the integral from 1 to 4 of f of x dx? What do you think the answer is here? So I'm given this, I'm given that, I am asked to find this, which is 0.3. If you look at the limits, right, as f of x is the same. If you look at the limits, we're starting here at 1, we're ending here at 4. We're starting here as 1, we're ending here at 2. We're starting here at 2, we're ending there at 4. This is basically just a combination of these two. Okay, so this is basically just equal to 1 plus 2. Okay, so you are finding the combined area of the two definite integrals above. So definite integral 1 and definite integral number 2. So that's also another hint. You could get questions like these where it's basically just given to you in this form, asks you to find this, just testing basically your understanding of the whole problem of definite integrals, as well as how the areas under the curve work. So these are two good hints just to remember. I know my lecturers try to trick us and give us something like this with very little information, trying to test your knowledge on it. However, all the information was given to you. You just needed to understand how definite integrals were working. So stay tuned. I will upload more videos around definite integrals, especially some other examples. I haven't gone through a lot, but I just wanted you to get the basic understanding of what a definite integral is, understand some examples, and also be able to recognize how you use the definite integrals. But like I said, a lot of the rules I've explained to you in my indefinite integrals video, and please go to my channel and check that out. Until next time, take care, and we shall see you again on the next video.